Let's start with an empty spreadsheet. We are going to solve the linear programming program that is shown in the blue box. We see that we have 5 decision variables: x1, x2, x3, x4, and x5. We type the notation in cells B1 to F1. Later on, we will put the information that is related to these 5 decision variables in columns B to F. Then, just like what we do when we formulate a linear programming problem, we start with the decision variables. Let's put the decision variables in cells B2 to F2. And let's mark those cells yellow so that later it is easier for us to see them. Recall that decision variables are the quantities that the decision maker can choose to optimize the objective. And these quantities are unknown before we solve the problem. Therefore, we will leave cells B2 to F2 blank for now. The second step is to set up the objective function. This is a maximization problem, and let's take a look at the objective function and check the coefficients. Because the objective function coefficient for x1 is 0.053, so we put 0.053 in cell B5. Similarly, we can put the coefficients that are corresponding to x2, x3, x4, and x5 into cells C5, D5, E5, and F5 respectively. After we identify the objective function coefficients, we are ready to set up the formula to calculate the value of the objective function in cell B6. The formula is the sum product of the objective function coefficients and the decision variables. We mark cell B6 green so that later it is easier for us to find this cell that represents the objective function value. The third step is to set up the constraints. We will identify the coefficients for the decision variables in each constraint, and then utilize these coefficients and the cells of the decision variables to set up the constraints. In particular, we will set up the left-hand side and the right-hand side of each constraint. For example, constraint number 1 contains only one decision variable, x1. You can think of constraint number 1's left-hand side as 1 times x1 plus 0 times x2 plus 0 times x3 plus 0 times x4 plus 0 times x5. Therefore, the coefficient for x1 is 1, and the coefficients for the rest of the decision variables are zeros. Now, we can set up the constraint number 1's left-hand side by calculating the sum product of the cells that represent constraint number 1's left-hand side coefficients and the cells that represent the decision variables. The sign for the equation is greater than or equal to, and the right-hand side can be calculated as 0.2 times 500,000. Similarly, we can identify constraint number 2's left-hand side coefficients that are related to the 5 decision variables. The coefficients for x4 and x5 are both 1, and the rest are zeros. We set up the left-hand side formula with the sum product of these coefficients and the decision variables. Now, indicate the sign and enter the right-hand side value of the constraint. We will do the same thing for constraint number 3, constraint number 4, and constraint number 5. The non-negativity constraint in equation number 6 says that all the decision variables are non-negative. We do not need to set up this constraint as what we do for the previous 5 constraints. The reason is that there is an option in Excel Solver for us to include the non-negativity constraint automatically. We will see that option later. Before we start to solve the problem, I'm going to point out a tip in setting up the left-hand side of the constraint. If we look closely, we will find that the left-hand side formulas are almost identical with a minor difference in the location of the left-hand side coefficients. So we can set up the left-hand side of the first constraint and add the dollar sign in front of the location of the decision variables to fix these cells in the formula. Then we can move the cursor to the lower right corner of cell G9. When a cross appears, click and drag down to fill the formula for the rest of the constraints. I use the black box to mark the left-hand side and the right-hand side of the constraints, so that they are easier to identify later. Now, we have set up the spreadsheet for the linear programming problem, and we are ready to use Solver to solve the problem to optimality. Solver is under the Data tab. Click on Solver. The pop-up will ask us to set objective. Click the cell we set up the objective function formula, which is B6 or the green cell. The next option is to choose the direction of optimization. Because this is a maximization problem, we will click Max. Then the next cell says by changing variable cells. This is where we need to tell the solver the location of the cells for our decision variables, which are the yellow cells. Next, we will enter the constraints by clicking the Add button. We will add one constraint at a time, and we start with constraint number 1. The cell reference is the place we tell the solver in which cell we set up constraint number 1 left-hand side formula. Choose the corresponding sign for constraint number 1. Then we tell solver in which cell we set up constraint number 1's right-hand side in the last box in this pop-up. Then we click the Add button to add the next constraint. We will do the same for the rest of the constraints. After we finish entering the last constraint, we click the OK button to return to the solver pop-up. Now, we have all constraints entered except for the non-negativity constraints. We'll click the option that says Make unconstrained variables non-negative. Then, to solve this problem, make sure that you choose Simplex LP as the solving method. Then we click Solve. It will take a few seconds for the solver to find the optimal solution. When the results pop-up appears, choose Keep Solver Solution and the sensitivity report, then click OK. Now, we can see the solution from the spreadsheet. The best value for x1, x2, x3, x4, and x5 are in the corresponding yellow cell. The maximum possible objective function value is 43,700. The sensitivity report is put in a separate spreadsheet. We will talk about how to read it in the next module.